In this video, we're going to continue topic 8.11 where we're talking about the washer method. In example 1, we're going to find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals the square root of x and y equals the square root of x, or y equals x squared, and we're going about the x-axis, sketch the graph, and draw a representative rectangle. So important things to note in the problem: that we've got square root of x, and that we've got y equals x squared. It tells us that we are revolving about the x-axis. And we have to draw that picture. So I'm going to start with the square root of x. I know when I put a 1 into the square root of x, I would get 1. So I know the point 1, 1 is on the graph. And be careful because look at the scale. I also know 0, 0 is on the graph. And I know a square root function looks like that. So it's like a half of parabola laying on its side. So that's the square root of x. So this is my f function. And then this one is a parabola. I know it also has a point at 0, 0, and 1, 1. And it's like half of a cup going up. So this is the region that we are revolving. We know that it's a washer because there is a gap. See the gap between our axis of revolution, because this is the axis of revolution, and the actual yellow area. It's only really touching in one point. So if it's touching in 1 point or less, then we know that we have a washer. So I know that the blue one is the function that is further away. If it helps you to kind of highlight your axis of rotation, the blue is further away from the axis of rotation, so that's going to be my outer function. And the purpley one is going to be my inner function. And then we do the top minus the bottom. And in this case, our bottom is going to be y equals 0 because that's the x-axis, our axis of revolution. So I'm going to go ahead and set this up. So we know whenever we do a revolution, we start with pi. We know from our graph and sketching that we're going from 0 to 1 for our bounds. All right, I'm going to do my outer function first. So remember, so this is the outer function. The top curve is the square root of x, and the bottom curve is the y equals 0. So this is the bottom curve. All right, and then I'm going to subtract. And now we're going to do the inner curve. So my inner curve is x squared, and I'm going to subtract the bottom again, put a dx at the back. So this again is my axis of rotation. All right, let's see if we can get this integrated. So we have this, the 0 doesn't matter, so the square root of x squared would just be x, and then minus the square root of x squared would be x to the 4th dx. When we integrate that, I still have a pi hanging out in front. We've got x squared over 2 minus x to the 5th over 5 from 0 to 1. And then I'm going to plug in the 1. So we've got pi. 1 squared is 1. 1 to the 5th is still 1. And then minus, we would have pi. Plug in the 0. 0 squared is 0, which is going to make the whole thing 0. 0 to the 5th is 0, which is going to make the whole thing 0. So this back piece is just going to be 0. Technically, I could leave it like that. I could also make a common denominator. My common denominator would be 10. I would have to multiply the 2 by 5, so this would be 5 tenths. I would have to multiply the 5 by 2, so this would be 2 tenths. So I would have 3 pi over 10 as my final answer.